10 seconds. 9, 8, 7, 6, 5.
Welcome to our adult education webinar this afternoon on the college and career readiness standards, specifically focusing on mathematics. So a little bit ago, the New Teacher Project conducted some research involving 5 school districts, 1,000 lessons, 5,000 assignments, 20,000 student work samples, and 30,000 student surveys, and spent considerable time reviewing all of this student work as well as actually watching lessons, and compiled all of the information they found. And what they found was that, first of all, by and large, students are doing exactly what they're asked to do. So 80% of the students in this study earned at least a C, so that indicated that they were successful. However, even though they were successful in doing what they had been asked to do, only 17% of the students were demonstrating mastery of grade level standards on their assignments. And again, that's not because they weren't doing what the teacher had asked them to do. They were getting C's or better on their assignments. And only 29% of A students were actually meeting the state assessment's grade level bar. And so what they said was that ultimately students do what they're asked to do, but the issue is that many of them aren't being given the opportunity to grapple with grade level appropriate content. And through that research, they found that 74% of the time spent in core classes was on assignments that were not at grade level. And so their conclusion was that students are kind of being given a false sense of success when they're doing what they're asked to do and they're told that they're being successful, but then they're going on to a college or employment and not having the skills that they really need to succeed. So I really thought this was interesting and highlighted the importance of focusing on the college and career readiness standards, because those standards identify what really is going to help those students succeed in college and career and be successful. So the math standards are set up a little bit differently than the English standards. Well, let me talk to you first about how the college and career readiness standards for adult education were actually established. The standards were published in 2013, and they were a subset of the Common Core state standards. So what happened was that a group of subject level experts were convened, and they addressed these questions, which were: what content in the area of mathematics is most relevant to preparing adult students for success in higher education and training programs, and which standards in each content area are most important for adult students. And they really were focusing on the idea that adult education students typically spend a lot fewer hours in class than K-12 students, and so we really need to focus in on those things that are the most critical for success. So the process that they went through was deliberative, multi-layered, iterative, and evidence-based. So the standards that they came up with, they're not a set of federal mandates, and they're not a level of hierarchy for what's most important, and they're not specifying how instructors should teach. What they are doing is defining what a student should be able to know and do to be prepared for post-secondary success. The standards aren't a curriculum. They're not representative of the full spectrum of support and interventions appropriate for ELL or special needs students either. So again, the math standards are organized a little bit differently than the English language arts standards. They still are organized into 5 levels, A through E, but if you see on the slide, you can see that they're level 6 is actually split between level C and D, or grade 6, sorry, is split between level D and E. So, and they're aligned with the ABE levels from NRS. So level A would be ABE1, about K through 1 grade levels. Level B is 2nd and 3rd grade, ABE2. Level C is grade level 4 and 5, and a little bit of 6, ABE3 level. And then D is the rest of 6th grade, 7th and 8th grade, and ABE4. And then level E is all high school. So that would be ABE 5 and 6. This is an example of a mathematical standard. The mathematical standards don't have anchor standards like the English ones do. They're based on level. So all of level A's will be listed together, and then all of level B. And there are many different subsets. So you can see this one in level A, there's a number in operations, and then there would be all of the standards that are listed underneath them. The CCR standards were developed to reflect and exemplify the 3 key advances of focus, coherence, and rigor. So focus works in conjunction with the other 2 key advances of coherence and rigor to prepare students who are college and career ready. It's critical that teachers focus their instruction if students are to learn key topics at each level deeply, meaning they possess conceptual understanding, they have fluency in procedural skill, they can apply their knowledge and skills to solve problems in real-world situations and in a variety of contexts, not in just the manufactured ones that you might find on a math test. It's also important that both teachers and students have a sense of how the mathematical topics they're addressing, both within and across the levels, connect and build on one another. So not only with the college and career readiness standards do we have these new advances of focus, coherence, and rigor, but there's also another layer of thinking that's important for adult learners to be college and career ready, and that's the standards for mathematical practice, which are really the habits of mind that allow us to think deeply about mathematics. And we'll talk more about those standards later on. So we're going to dive into each of the key advances for a moment, and we're going to start with focus. So what does it mean to focus? High-performing nations significantly narrow the scope of content so that students can focus their time and energy, as the TIMSS research tells us. College faculty in the U.S. believe that narrowing the content scope is essential to building strong foundations in students. So the college and career readiness standards for adult education ask instructors to significantly narrow the content and deepen the understanding of the mathematics they teach. A study of the college and career readiness standards demonstrates that there are areas of emphasis already engineered into the standards at each level. So you can identify kind of the focus of each level and focus in on those. It's equally important to deepen expectations as well. So instead of skating through a whole bunch of topics and just barely touching on any of those, it's more important to choose fewer topics and really build in deeper understanding for those topics. Without focus, deep understanding of core math concepts for all students is just a fantasy. Focusing opens the door to strengthen understanding. Fewer topics on the list means more time to spend on each one. Focusing will allow students to acquire strong foundational and conceptual understanding, procedural skill, and fluency, and the ability to apply the mathematics they've learned in solving all kinds of problems both inside and outside the math classroom. Additional content can and should be taught, but in support of and connected to the major work of each level. For example, data representation and interpretation is not the major work of level B, but some of those standards can be used to better understand fractions and standard units for linear measure by asking students to generate measurement data by measuring lengths using rulers marked with halves and fourths of an inch. So here are some things to consider when you're focusing instruction. the amount of time that you're dedicating to a concept, the quality of the classroom activities, reasoning, and explanation, what kinds of student practice and how much student practice you're requiring, and the rigor of expectations. So all of those are parts of making a focus on the major work of the level. And don't forget that the standards for mathematical practice are an essential part of the college and career readiness standards and need to be embedded into the classroom lessons that you teach. So notice that the critical concepts of levels A and B are restricted to the domains of numbers and geometry. However, both levels also include standards addressing concepts in algebra and data. Those standards will need to be connected to one or more of the major concepts in number or geometry. So one thing you'll want to begin to think through is how the concepts of algebra and data might be used to support the critical areas of number and geometry. For example, one of the data standards talks about generating data by measuring lengths using rulers marked with halves and fourths of an inch. This supports the developmental work being done at this level to build student understanding of fractions and actually the representation of fractions on a number line. In level C, we expand the system of numbers to include operations with all positive rational numbers. Critical areas are still more heavily weighted to the number and geometry domains, but at this level we introduce critical concepts in the algebra and data domains. So you can see that there's still a lot of concepts to be covered, but we're still focusing in on that, on specific ones. Level D, we expand the number system to include all rational numbers, negative and positive. Rates, ratio, and proportions are a key focus. There's also an increase in the number of critical areas in the domains of algebra, including work with linear expressions, equations, and functions. Data and probability also come into the fore. And finally, at level E, we include all real numbers, bringing in the irrational numbers as well, and you notice that we now have the majority of critical concepts in the algebra domain. So you can see as how those concepts advance through the levels and the focus changes as the concepts advance. So once we've determined what we need to focus on, the second key advance is coherence. Remember that coherence works in conjunction with the other two key advances of focus and rigor to prepare students who are college and career ready. It's critical that you appreciate the flow and progression of content within and across the levels of the college and career readiness standards and see the connection to the major work of the levels. And as you are looking at the focus, the major work of each of the levels, and you're focusing in on those, don't forget to build in the coherence where you're linking back to what they've already learned and kind of previewing what will come in the future. Standards and curricula within the United States have typically not been particularly coherent, with significant repetition across grades or levels. The college and career readiness standards for adult education have been purposefully developed to have clear progressions across levels and meaningful connections between concepts made both within and between levels. Instruction at any given level benefits from being informed by a sense of the overall progression of learning that students experience across the levels. This progression allows instructors to be able to count on students having conceptual understanding of certain core content. Instead of each standard signaling a new or isolated concept or idea, standards at higher levels become extensions of previous learning. For example, the focus on understanding numbers and their properties across the levels exemplifies the progression from number to expressions and equations, and then to algebraic thinking, algebraic expressions and equations, and ultimately to a deep understanding of functions. These connections can be further exemplified in applications related to other domains within and across the levels, such as the connection between properties of operations like multiplication and geometric applications like area. So if you don't understand multiplication, you're not going to understand area. And building in that coherence and bringing them back to the concepts, the deeper understanding that you've built around those earlier concepts and applying that to increasingly more difficult concepts in the future. So lessons build new understanding on foundations built in previous lessons or levels so that content unfolds meaningfully. These explicit connections between concepts are not only made in lessons across the levels, but also within each level. Students and teachers begin to expect knowledge and skills to build and grow. Again, each standard is not a new event, but rather an extension of previous learning. This is especially true if instruction is focused strongly where the standards focus. So let's address the third key advance, which is rigor. As you learn about rigor, it's critical that you understand that college and career-ready students need to have conceptual understanding, procedural skill and fluency, and the ability to apply their mathematics knowledge and skill to solve problems. So it may be that there's a conception that increasing the rigor means increasing the difficulty of the problem, and that is not necessarily the way that we want to think about rigor in this context. In this context, when we're talking about rigor, we're talking about addressing all three issues together, and those three issues being conceptual understanding, procedural skill and fluency, and application. So research indicates it is not enough for students to know how to perform mathematical procedures by rote. They must be able to use those concepts to solve problems. Knowing more than how to get the answer allows students to generalize knowledge to new situations. Being able to perform core calculations quickly and accurately allows students to extend to more complex mathematical thinking. And asking students to apply their knowledge to a variety of problems makes mathematics relevant and practical. Deep conceptual understanding, fluency, and application must be connected to those concepts that are most critical for each level. Conceptual understanding is being able to understand deeply the concepts that are behind the procedures. So lessons should help students deeply understand key concepts and see math as more than a set of discrete procedures. For example, students need to comprehend how they can know for sure that 7 times 8 is 56, instead of just memorizing that 7 times 8 is 56. Fluency is about getting them comfortable enough with the operations and procedures to do it quickly. So some class time and homework should be devoted to students' practice with calculations and mathematical procedures so they gain speed and accuracy. Once they understand that 7 times 8 is 56 and they can understand like what that actually means, they need to be able to just know that 7 times 8 is 56. And then the last one is application. So that's fluency practice is critical, but it's not an end in itself just because they know that 7 times 8 is 56. If they don't ever know when to use that, it's not actually really that helpful. Once they're fluent, that's used to support problem solving and deeper mathematical thinking. So that brings us to the standards for mathematical practice, and these are my personal favorites because I think it extends to actually concepts outside of mathematics and just learning to think about problems in general, and those problems can look very different than actually just, solving 7 times 8. So they're kind of separate from the college and career readiness standards, but the intent is for them to be infused into lessons and integrated into teaching and learning so students experience them as they are learning level appropriate content. So you can see the first one is about making sense of problems and persevering in solving them. And I don't know how many of you have had students ask you why we have to learn algebra when I'm not ever going to use algebra ever again, or why do I have to figure out the quadratic equation when I'm never going to use that in my real life. And this concept of making sense of problems and persevering in solving them, I think, is my favorite go-to answer, I guess, because even if they never use a quadratic equation again, learning how to use the quadratic equation teaches them how to solve a problem and also helps them to persevere. And then they know that they can think through hard things and come up with an answer. those are valuable life skills that can be used in a variety of situations outside of the classroom. The second one is to reason abstractly and quantitatively. Sometimes that's exactly where students run into trouble. They can do the more tangible aspects of math, and if you tie it to money, they could solve that problem really easily. But once you write it down on the paper with symbols, then they get lost. And so making that transition is very helpful in, again, a variety of other contexts, being able to think abstractly and quantitatively. The third one is constructing viable arguments and critiquing the reasoning of others. And this is where, when you're teaching, you ask why is that true, and have them explain their reasoning, and having them explain the reasoning of others. Is that right? What Johnny said, is Johnny's answer right? And then they can justify why it is or isn't right. And that also helps you to identify thinking errors and correct the way that they're thinking. But the viable arguments and critiquing the reasoning, those are skills that are embedded in the college and career readiness standards for language arts as well. And again, a critical skill that can be used in a variety of contexts outside of the classroom. So the fourth one is modeling with mathematics. And that's maybe a little more applicable to mathematics and specifically, but I guess modeling just period can be used in so many other contexts. Using appropriate tools strategically, again, when you're thinking about job and occupations, you have to identify quickly which tool you need to use for any problem, any job that you're using, and then using that in the appropriate way. Attending to precision, that's an important skill to have. Looking for and making use of structure, finding patterns, and being able to explain those patterns and repeat those patterns. And then looking for and expressing regularity and repeated reasoning. So I really like those. I think they're very applicable outside of math and can help provide reasoning for why we teach mathematics and why it's a critical skill for students to have, even if they never use the quadratic equation again after they graduate. These standards for mathematical practice rest on processes and proficiencies with established significance in mathematics education, including such skills as complex problem solving, reasoning and proof, modeling, precise communication, and making connections. Such processes and proficiencies have been reflected in earlier documents from the National Council of Teachers of Mathematics in 1989 and 2000, and the National Research Council in 2001. Surveys with employers and professors of entry-level credit-bearing math courses attest to the importance of students being able to demonstrate the capabilities defined in the standards for mathematical practice. The standards for mathematical practice define ways students are to engage with the subject matter as they grow in mathematical maturity and expertise across levels. The college and career readiness content standards are a sequence of topics and performances that reflect a balanced combination of procedural fluency, conceptual understanding, and applications. This content is intended to be connected to the standards for mathematical practice across domains and at each level. The standards for mathematical practice provide students with a flexible base from which to solve similar problems, represent problems coherently, justify conclusions with sound reasoning, and use technology and tools mindfully. Processes and proficiencies defined in the standards for mathematical practice are important for students when they transition to college or work, giving them the understandings they will need to apply their mathematics to new situations. Teachers need to focus on how to integrate the standards for mathematical practice into lessons related to specific content. Evidence of application of the standards for mathematical practice will need to be included in assessments, both formative and summative. For any given lesson, the focus should be on only those standards for mathematical practice that are central to the lesson. So even though those are all useful skills, it's not necessary or even prudent sometimes to have them focused on, like, embedded in each lesson. Other standards for mathematical practice might be relevant in a supporting role, but some might not be relevant at all in that particular lesson. It's important that students are given opportunities to experience all 8 standards for mathematical practice over a course or level, but not in a single lesson or unit. The goal is to eliminate the habit of listing all 8 standards for mathematical practice at the beginning of a lesson or unit and advising the teacher to address them. So they should be used judiciously in focusing, back to the beginning, right? Focusing them on ones that are more applicable to each individual lesson. So in sum, when you're thinking of the mathematical college and career readiness standards, remember that the key advances are focus, coherence, and rigor, and that you're wanting to change the way that you're instructing students to make sure that you're incorporating all of those to better help them build the standards for mathematical practice and ultimately prepare them for college and career readiness. Thank you. I guess I should disconnect, huh?
I think we're good. His screen won't work. But nope, it's still connected to yours.
Yeah, me too. It just wasn't coming back up. Nope. Cool.
Are we all clear? Yeah, like we're done.